Hi, this is Asing. You are now watching Asing Math TV. Today, we'd like to share how to evaluate this limit by using squeeze theorem. Consider this unit circle with a few triangles on it. From here, we should be able to notice that the area of the triangle OBC is greater than the area of the sector OBD and is greater than the area of the triangle OBD. However, our intention here is to determine the limit when the angle X is sufficiently small enough and approaches 0, which means that there is a chance where the three areas are exactly equal. Let's first evaluate the area of the triangle OBD. Consider the triangle OBD with angle X here. Recall that the area of a triangle is equal to 1/2 multiply base multiply height, which means that we should have 1/2 multiply the base, that is OB, multiply the height, that is AD. And we know that for any unit circle, the radius is always equal to 1, which means that OB is equal to 1. For the unknown AD, let's determine AD by using trigonometric ratio. Recall that sin x is equal to opposite over hypotenuse. If the angle X is here, for the triangle OBD, opposite is equal to AD, while the hypotenuse is equal to OD. That is the radius of the unit circle, which is equal to 1. In other words, AD is equal to sin x. Let's substitute here sin x. Therefore, the area of the triangle OBD is equal to 1/2 sin x. Next, let's determine the area of the sector OBD. Recall that the area of the sector OBD is equal to 1/2 multiply radius square multiply the angle, that is x, which means that the area of the sector OBD is equal to 1/2 x. Lastly, let's determine the area of the triangle OBC. So we should have 1/2 multiply the base, that is OB, multiply the height, that is BC. Again, for the radius, which is equal to 1. And for the unknown BC, let's determine by using trigonometric ratio. This time, I'm going to consider tangent x, which is equal to opposite over adjacent. Therefore, we should have BC divided by OB, which is the radius of the unit circle, that is 1. In other words, BC is equal to tangent x. Let's substitute here tangent x. And we know that tangent x is equal to sin x over cos x. With all this information that we obtain, we can now evaluate the limit. We should have 1/2 sin x is less than or equal to 1/2 x is less than or equal to 1/2 sin x divided by cos x. Let's multiply the entire inequality by 2, and we should have sin x is less than or equal to x is less than or equal to sin x over cos x. Next, I'm going to divide the entire inequality by using sin, and we should have 1 is less than or equal to x divided by sin x is less than or equal to 1 over cos x. Since our intention is to determine the limit for the function sin x over x instead of x over sin x, which means that we should take the reciprocal of this function, and thus the inequality should become cos x is less than or equal to sin x over x is less than or equal to 1. Next, let's just apply the limit. When x is equal to 0, cos x is equal to 1, and this is less than or equal to the limit x approaches 0 for the function sin x over x, and is less than or equal to, since 1 is a constant and nothing to do with x, which means that the limit when x approaches 0 for a constant 1 will still be 1. And hence, by using the limit squeeze theorem, we conclude that the limit for the function sin x over x when x approaches 0 is equal to 1. And hence, we're done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.